Fusion Middleware Division. So we're the group that actually makes all the portal products, in particular, things like Oracle Portal, Web Center, and various other products that you may have dealt with in the past, like ModPL SQL, etc. So, and basically I look at the security side of what we need to do when we build these types of applications, particularly as we're moving towards the rich internet architecture or the Web 2.0 environments. First things first, just basically what we're going to cover, as said, Web 2.0 is a nice piece of architecture, but what does it really mean? I mean, we talk about Web 2.0 being rich internet apps, and we talk about Web 2.0 being Flickr and Facebook and things like that. But what sort of characteristics define Web 2.0 applications, and are they relevant from security? And the problem is, yes, they are, very much so. So we'll look at Ajax in particular, and for those who went to Frank Nymphius's presentation this morning, you'll see some of the overlap there. We'll looking at RIA, or Rich Internet Applications, from an enterprise application viewpoint. And one of the big changes in Web 2.0 is traditionally it's been a public internet thing. We just saw Flickr in that very good demo in the previous session. But Flickr isn't really what you'd call an enterprise app. You're not expecting your CEO to suddenly leap into Flickr to try and work out his ERP system. So what do we need to do in terms of enterprise applications to enable us to take that one step further to make them secure? One of the characteristics, as I said, social networking, and that's a part of Web 2.0 that's very popular out there on the web. But we're starting to see it come into play inside the enterprise, inside companies. And a new term you may have come across, we've heard about mashups, but what's an enterprise mashup? Where does one stop and the other one start? Well, Web 2.0, as I said, it's buzzword compliant. I probably have more buzzwords on that one slide than we really need. But really what it comes down to it is there are a number of different technologies that make up various components of a Web 2.0 application. But it's not really a technology, it's a mindset. Web 2.0 is a combination of three distinct avenues of web design. Now, we've seen a lot of, at the conference so far, on rich internet applications. The interactive stuff that people see in Google Maps and Flickr and things like that. However, one of the big changes is the concept of loosely coupled applications. Now, you would have heard of other acronyms like SOA. Well, SOA and Web 2.0 go hand in hand. The definition of a SOA application is a loosely coupled application. The definition of a Web 2.0 application is, again, loosely coupled. If you look at a mashup is loosely coupling different applications into the one application. Likewise, when we look at collaboration, we're really looking at the concept of bringing people back into the picture. In other words, the relationship between the users themselves is as important as what's physically on the screen. It's how people relate to the information as opposed to how they necessarily get to the information. Now, the problem with security is people are inherently untrustworthy, and that plays fairly significant, or has a fairly significant impact on how you design your Web 2.0 application. So as I said, rich internet applications, traditionally the goal, as we saw previously, was to make our web application or our web experience similar to the client server. In other words, all the pop-ups, the drag and drop, and all the sorts of things you'd have in desktop. And basically, in the HTML world, we've been focusing on Ajax as a way of doing the out-of-band communication. But that in itself has some issues, which we'll discuss. However, one advantage of rich internet applications is they are actually more, in some ways, more scalable because you're only going across the network when you absolutely have to. I'm keeping processing on the client. If I don't need to go across, then the bandwidth consumption on the network is actually less. So that's a positive thing. As a collaborative web, and this is where we have things like our Facebooks, MySpace, etc. There's sort of the thing that most people see when they talk about Web 2.0 out there in the real world, because it's what they get to see. It's what they actually associate when they go online. But really what we're talking about is a number of different human interface type technologies that allow people to either define the content themselves or find content by defining what it means to them. So by that, obviously we have things like wikis and discussion forums where people can go and enter their own pages. But then we start talking about tag clouds and RSS feeds. So in other words, allowing people to not only write information, but define the metadata themselves that allow them to then find it. But you can imagine a situation, for example, if I defined a tag as company acquisitions. So I've gone in there as the CEO, and I've typed the thing going, oh, I'm going to write a list of all the companies that we're going to buy in the next 3 months. And I put a tag cloud in so I can find that document again. Someone else can just come along and go, acquisitions. Ooh, we're buying those. Quick, go buy the stock. But so simple people interaction in itself becomes an issue. And then mashups, as I said, it's really the idea of combining more than one disparate source into a single application or a single integrated service. And when we talk about enterprise mashups, we take that to the next level. We're not talking about going and getting a Google map and working out where the ATM is. We're saying, let's take our HR system and bring in, for example, our salesmen and their quotas. We'll bring in our ERP system, we'll bring in our invoicing system, and we'll present it as one application. So you're actually going off and getting quite sensitive information from different places and targeting the one transaction. Was that a question or a hello, I'm here? And another acronym. This industry would not work if we didn't have acronyms. Obviously, 3-letter acronyms were not enough. We have to go 4. And preferably if we put a J in front of it, it'll be Java something or other. So yet another acronym for you. But basically, these things, they're really defining a SOA-based application into a mashup. Okay, so let's actually get to the meat of things and look at the security. Excuse me a second. So when we look at web applications and Web 2.0, they're fundamentally, the basic goals are no different to what we would have had in any other web application. The information, we're trying to make sure that people who aren't authorized to see the information don't get to it. We want to make sure that no one can spy on it. And more, we want to make sure that we don't have denial of service. As people go more and more transactions on the web, if they can't get to it, their business goes down. Conversely, we also want to protect the application from the end users. We tend to focus on making sure that the user is protected, but we have to make sure now that the application is out there and the user is the person writing it, that we also protect it from the malicious end user. So why are we particularly concerned with Web 2.0? Well, all the things that make Web 2.0 exciting, like the dynamic content, like the loose coupling, like the social interaction, are also its biggest weakness in terms of security. If I can go and add things to a page, what's to stop me going adding something malicious to a page? So what we need to look at is how do I prevent things like malicious use of a segmented application, because we're loosely coupled, or when we look at Ajax, our code is now segmented across the client and the server. And the two are separate sessions. How do I keep them in sync? How do I prevent someone using the application in a malicious way? How do I prevent exposing holes? In other words, and we'll talk about this in a second, but I've developed, for example, a booking system where I check for my credit card and then I go and book something. Well, if I can bypass check for my credit card, I can just go and book something and never pay for it. All of that code would have been together originally, and we sort of separated them apart. And the human network is always one that's very difficult because you can't secure people that well. You can't stop someone physically typing into the page. So what we have to look at is not trying to stop the person typing, but stopping anyone seeing what they have typed. There's a slight difference in the way we look at it. So let's start off by looking at the Ajax model. And there's been a number of presentations over the conference where people have been talking about the XML HTTP request object. But traditionally, in a normal web application, all our code was sitting over here on the server, nicely protected away. The end user couldn't get to it. In that environment, a page request downloaded the entire page. In the Ajax space, obviously, some of the code that was over here, if we had a number of methods, have to be called from the client to activate that. Previously, if this was check credit card, buy object, check out, then the application would call those there. But if the UI has to call it, what we end up with, in this case, we've got some form of user interaction. I'm searching for an object. So we have that request being redirected to our HTTP request object, which then goes away and calls that method at the back end. We're going to get some form of HTML or XML document back, which is then obviously passed to a callback function, which will go off and basically update our DOM, or the document object model. So in other words, in this case, we're pushing part of the UI functionality into the client, but we're also passing part of the business flow into the client. So in other words, the order in which we process our orders, or the way we process the actual functions, is now being orchestrated in JavaScript in the client, which in itself is fraught with danger. Obviously, when we submit the page, it's going to go back as a normal page submission, or the whole HTML page. Now, Ajax has a number of security considerations we have to look at. First of all those Ajax requests can take place without the end user ever actually knowing they're going on. So if there is malicious code there, it can quite happily go on in the background, and the user doesn't know about it. Conversely, at the server end, it can't tell the difference between a URL that was sent for the post of the page or a GET request for the page than a GET request from the URL HTTP request object. So in other words, as far as the server is concerned, they're effectively two separate browsers asking for a particular method. The thing that is concerning is, unlike the browser, there's no ability to encrypt that traffic. There's no PKI support. So I can't pass certificates and things. So I can't encrypt the information and say, well, that's absolutely who you say you are. Whereas from a browser, it is. Now, there are some things, other things that the XML HTTP request, because it's based on JavaScript, JavaScript does promote the same server domain security policy. So in other words, by rights, if I issue a URL, I can only go to a server that the original script or the original page came from. However, it's very easy to get around that. If you do a lazy load, for example, through a source image, it can come from anywhere. So you can actually go and get JavaScript from completely different servers than the original page was loaded from. So that's something you have to look at and go, ooh, well, we shouldn't have that. Now, you'll come across JSON objects. JSON as a notation for JavaScript objects is a simplified version of JavaScript in itself. So if I'm passing information up and down between the client and the server and saying, okay, that XML document we saw before in the diagram beforehand, there's nothing to stop me having that XML be JSON. And if that JSON is actually just JavaScript hidden as objects, I suddenly have an attack vector that I didn't have before. This is an interesting one. When we look at the document object model, and in fact with any JavaScript, you can't actually hide it. So any code that you have downloaded, you can actually see the code, which means you can manipulate that code or play with the code. So just that in itself makes it very hard to keep intellectual property of what your application actually does. So when it comes down to it, Ajax applications use the client, but they don't actually control it. So you can almost think of it as having like two separate browsers, where this browser does one set of processing and this browser does another set of processing. Now they happen to be the same UI, but effectively they're completely different sessions. So you have to then try and keep the two in sync, and that becomes a nightmare as far as just pure Ajax coding. The other thing that people often do with JavaScript is they obfuscate the code. They make it very hard to read. However, there's some very good JavaScript debuggers out there now, which work backwards. So even with obfuscated code, you can see what the original code is. So don't rely on obfuscation as a way of trying to protect your Ajax code. It just doesn't work. People can get past it. Okay, so when we look at it, Ajax or rich internet applications basically have a number of areas of security violation. And they do that predominantly by increasing the surface area, if you like, of the attack surface, but also the number of vector points that you can actually attack. So for example, I can look at the code. I go, show source. Oh, that's what their application is doing. So let's go back to our credit card check. I can bypass. So if my code on the client says, validate this credit card number or date or whatever, and it's processed in the client and then calls order. Another one, particularly for e-commerce sites, is denial of service. Let's take the situation, for example, on an auction site. And there's something on bid, and locks up the auction. So no one else can actually physically get in because I have locked up that method call. So in other words, I'm denying that. Then all I have to do is wait for the auction to expire and go pay. So in other words, having access to the code allows me to see what the thing does and then obviously be able to circumvent that. Now, the other side of the coin is the dynamic content. One of the big issues you'll run into in dynamic content isn't actually a new problem. It's been a problem for ages, particularly when you're looking at reflected cross-site scripting. How many people have been to a website where you go, log in, Barry, and it comes back and goes, hello, Barry? So in other words, it's personalized. It's got your username at the top. What's to stop my username being open script, send all my credit card details somewhere else, close script? It's going to come back and go, hello, oh, execute script. And suddenly all my cookies are sent that way. So when we talk about cross-site scripting, what we're looking at is the ability to put malicious code into an application that is effectively reflected back at us. And when you look at it, when you're talking about wikis and discussion forums and rich text editors, there's nothing stopping me putting in any code I like, because it's just text. It's only the browser that recognizes it as script. So when it's reflected back, it's going to be executed. So we need to have a system that prevents that. Cross-site request forgery is a sort of a newer version of cross-site scripting. And that's really based on the fact that browsers keep your cookies around. So if you went to a banking website and you logged into your banking website and you didn't sign out, so if I then go to another website that's completely independent of that one over there, then it can have a piece of script that basically says, when I go to this page, pick up the cookie from over there and send it to this one. So the difference being is you're going back to the original bank, but you're sending the bank an invalid request from someone else, and it's using your cookie to do it. So it's quite severe in terms of what you're able to do. Cross-site scripting sends you somewhere else, effectively. Cross-site request forgery sends you to an original site, but with someone else's commands, but using your identity. And that's all to do with applications hanging on to cookies before you went to the other site. So, for example, if I had site A, which is my bank, site B, malicious site, I go to site A, I log on, I go to site B before I log out of site A. My cookie is still valid, it gets redirected. So let's have a look at some of those attack vectors. So as I said, same diagram we had before, but here we have hackers are us. So we have our application, which has a number of, in this case, our auction. So we've got a validate our credit cards, bid on the items itself, and ship the item. So the first thing as a hacker I'm going to do is go to that rich Ajax site and look at the source code to see if I can look at the JavaScript. And I go, oh, yes, I can. So what I'm going to do is, first of all, I can send the request to ship the item without doing anything else. Or in the case of an auction, I'm going to send multiple bids to make sure that no one else can bid on it and the value is correct. Or, in this case, we've got an example of using JavaScript to do a cross-site hack. So you can see here, I'm lazily loading some JavaScript code. So what we have is I've hidden the JavaScript code as the source to an image tag. So here I'm just going off and I'm grabbing the cookie that was from the other site and I'm sending it to my Hackers Are Us website. So unless we had some code in that validation there that specifically checked for script tags, there's nothing stopping me putting any valid JavaScript code in there and have it replayed when that screen is refreshed. So normally when you're building Ajax code in pure HTML, you have to have sufficient code in there that you check for every possible attack vector in that field. Now there's two ways you can do that. You can have blacklists or you can have whitelists. A blacklist is basically, let's ban every single character set that we don't think makes sense. That's very hard to do, especially as new combinations of characters come out for delineators all the time. You're much better off doing a whitelist where you say, here's the approved set of characters that make sense for defining someone's name. So that's going to be, for example, hyphens, quotes, commas, things like that. Not many people have chevron as part of their name, unless you're from California, or from Hollywood or something like that. You wonder if Hollywood actors actually have a a competition to come up with the silliest names for their children at times. Does the film industry have similar things here? Do actresses and actors come up with weird names for their children? I must admit, I was asking the gentleman before in the flex, are there any Indian actresses who aren't incredibly attractive? Anyway, so what it means is when we look at all this Ajax stuff, the sorts of security rules that we had for traditional web applications are no different for rich internet applications. The difference being is we have to be more aware of them and much more proactive at stopping them. So our mantra is, if the application doesn't control the client, we don't trust the client. So in other words, all that Ajax code, it's really nice, it gives us drag and drop, but we don't trust it. We assume it's malicious. Even if it's not, if you assume it's malicious, you're more likely to block any attack vector than simply assume it's correct. So, does this really mean that if I'm building these rich internet applications, I'm going to say, okay, well, if I want rich internet apps, I've got to have bad security, or if you want good security, you can't have rich internet apps. It's a sort of one or the other. Well, no, that's not true. And if you've seen a number of presentations, whether it's Flex or everything else, there are different technologies which allow you to do certain things. But the fundamental difference is where it runs. Does it run in the client, or does it run on the server? Many years ago, we moved away from client-server for a very good reason. You can't trust clients. In reality, the only place that's ultimately going to be secure is on the server at the back end. So if we take the viewpoint that Ajax isn't an integration layer as such, it's purely for UI manipulation. If we move all the code back to a server and then use a development framework that is designed to give us rich UI, but keep all the stuff on the back end. Keep our session on the back end. Keep our arrays and our hash tables. Everything else is on the server where they're nice and safe. So, for those who saw Frank Nymphius' presentation, Oracle in particular, and most of the industry, is looking at Java server faces as a way of doing this. And Java server faces moves away from the traditional J2EE environment to the concept of everything being a UI component that is bound to data at the back end. So we have a rendering object that is self-contained and allows us to have the same rich UI that we would have if we moved the JavaScript to the client, but in reality, it's all on the back end. And there's going to be there's several hundred of these things, which allows us to build that type of application. Now, the nice thing is, all the validation code is inherent in the application, is inherent in the component. So checking things like credit cards and everything else is going to happen on the back end. There's no way I can bypass that step if I fill in the field, because all it's doing is it's passing the contents of the field to the back end, and it will go through whatever transaction is defined in that system. So in other words, we stop looking at it as atomic methods and start looking at things as transaction blocks. And the transaction block gets implemented as we validate that field, not individual methods. Because it's a self-contained component, all the actual JavaScript to control the UI element is built into the component. So there's very little points that I can go and hack into the code, because the code that actually does things is hidden from the client. It's all in the back end. It's only bits that manipulate how the buttons react and things like that, which is in the client. Now, the other thing, as Frank mentioned, is because it's JSF-based, it's a series of tags in our Java file. So I don't actually have to understand JavaScript to get fully rich JavaScript-based or Ajax-based components. I simply set some properties on a component, and the framework will do that for you. Now, JSF, as I said, is an industry standard. And if we look at it, how this implements inside Ajax is slightly different. So previously, our Ajax communication, or our XML HTTP request object, went back to a servlet. What we have here is the Jsf Lifecycle. The Jsf Lifecycle basically is the thing that controls all your binding and how your pages interact inside the Java server faces lifecycle, or face. So I have my faces servlet, and it dictates which page goes to which, so my navigation flow, which objects are bound to what data sources and things like that. So in this case, when I create a JSF page, we load the page as normal with all the built-in components. And by the way, this is actually a cheaty bit here. This is actually a screenshot of the next generation CRM applications, which are all developed in this technology. But in this case, when we have the call to do the search, rather than calling into the method call, we're calling into the lifecycle, and the lifecycle interrupts that call and says, what does this make sense? Or how does this make sense in my transaction? Do I need to pass it JavaScript? Do I need to pass it to a data control to say, go and look up some information? So think of that lifecycle there as the controller of an MVC model, because effectively it is. The difference here is that JavaScript is just one more view in that MVC model. Now, there are a number of ways we could integrate this. We could have the JSF itself call into the JavaScript and generate the JavaScript. We could have the JavaScript separated. Or in fact, you could actually have JSF and servlet generating JavaScript, JSF generating the lifecycle. Don't do that. Because the problem is, if I have a servlet and the lifecycle, whereas they can see the session information, the servlet can't control the view. It can only look at bound or manage beans and things like that. If the lifecycle itself controls the JSF or controls the JavaScript, then they can actually get access to the same objects. So my JavaScript can reference the managed beans, can reference the current view state and things like that. Looking at is Ajax-based components where everything is compartmentalized and held at the back end. You can't physically get to the JavaScript code except for certain APIs which will allow you to extend how it reacts. It gives you out-of-box binding to data to objects, and I'll show you this in a second. But most importantly, as a developer, I don't need to know anything about Ajax itself. I'm implementing an Ajax-based application, but I myself did not write any. It's handled by the component. So here's a diagram that Frank also used. This is a basic model of the ADF faces component, where effectively on the left-hand side here, we have data binding, and in the JSF world, data binding is through JSR 227. It's a way of binding back-end services. So what that means is I can build a component where the back-end data source can be swapped out and something else can be swapped in. I don't have to go and change my JDBC code or my ODBC code at the front end. It just plugs into the back. But more importantly, at the front end of our UI layer or the view layer, we have our binding objects. I have a field which binds to some back end, which that thing there is the thing that defines our validation. The UI component is really a rendering engine. How do we render that UI? And part of that UI rendering is the JavaScript. And just to give you an idea, in Web Center, which is Oracle's Web 2.0 toolcase, we're going beyond the idea of components just being individual UI elements. I mentioned that one of the fundamental things of Web 2.0 is social networking, is things like wikis and discussion forums and things like that. Well, the question then begs itself, why can't my discussion forum be another component that I can drag onto the page? Why can't my tag cloud definition be a component that I drag onto the page? And everything, all the interaction and all the drag and drop that makes sense for a wiki should just be there. I shouldn't have to worry about building it. Well, that's exactly what you get with the Web Center environment. So all of the various collaborative tools really just become other UI widgets that you drag into your application. So rather than having to worry about how I integrate them and all the other security sides of the things, let the framework do that for me and let me just drag it in and say, there it is. And all the security about cross-site scripting and things is handled by that component. The other thing, of course, is as we move things to the back end, we want our security model to be much more secure. And this is where we look at evolving the security model used by the applications itself. And the one in particular that is taken off is the use of JAS, or the Java Authorization and Authentication service. Basically, it's the API which allows us to define permissions on resources, including objects and bindings and things like that, such that I can secure it by user, by role, and do it declaratively. So what it really means is, rather than writing code to secure things, what we're actually doing is defining authorization based on actions. Does this person have the right to view a page? Does this person have the right to check a credit card detail? So in other words, rather than having to code all that, we specify actions and then simply apply permissions to those actions all on the server. So on the server, we're going to have a policy store that maps our roles to, and you can't see it particularly well here, to the sorts of actions that people want to perform inside their application. So the policy store is all hidden on the back end. So from the front end, I don't see that. I can't go and change it. I can't influence the security from the client because the application is actually looking up a remote policy store on the server itself. Okay, so let's have a quick look at social networking. As always, I'm talking slower. Okay, so when we look at social networking, we have to take into account that of all the security holes, of all the attack vectors, the one that's probably the weakest is the one that has two legs and a pulse. People. It's very hard to stop people actually saying things they shouldn't. So, for example, I go onto my Facebook and go, "Hi, I'm Barry. I'm a product manager. And did you happen to know that we're going to buy coming up soon?" So the thing is, how do I stop someone actually putting information that people don't want other people to see in blogs and things? Well, short of standing over them every time they go to the keyboard, that's a very difficult thing to do. So as that content is added, we have to stop them publishing information they shouldn't really do. But more importantly, let's flip that around and say, well, okay, if we can't stop what they type, let's make sure that only the people who have relevant need to know can see it. So in other words, rather than stop it or trying to constrain people from typing, we simply change the audience that can see what they have typed. In other words, let's limit the audience in the disclosure. So here's Bob. He's a builder. And actually, do you get Bob the Builder here? The children's cartoon? Otherwise, that would be a very flat joke. But anyway, so you've got Bob here, and he's out there on his website, and he's typing in his wiki or he's typing in his discussion. So what we want to be able to do is to separate out the various communities. In other words, look at it from a standard ACL viewpoint. who has the right to see this information, and then apply it to our wikis and our discussions. So rather than stopping him typing it, only group over here has access to the wiki, only this one has access to discussion, or more importantly, only certain people can have access to given threads or wiki pages. So in other words, look at social networking in exactly the same way as we've been looking at security since the beginning of computing. If I don't have the right to see something, I don't see it. Wikis are nice and fast, but they can be anarchy. And if you don't apply security to them, you end up with a huge number of pages that you don't necessarily know are there. So if we can't stop people doing them, let's stop people seeing them. So first thing we need to do is differentiate the concept between a public internet and an intranet. By rights, anything that's on the intranet should be secured. Having said that, it's amazing how many people don't use common sense on public internet sites or public websites. And the basic policy with any internet chat room or wiki is pretend you're talking to a real person. So when you're putting up photos of yourself and things like that, have it as a photo that would actually represent you in a business sense, because you never know who's actually going to find that. You don't really want one of you in a duck suit or something like that, because it doesn't bode well. Okay, so given that even the most responsible people do make mistakes, we have to assume that all collaborative content is going to be sensitive and therefore should be secured. So we need to implement a proper identity management solution. So when we build our application, we have to take into account that, if at all possible, implement a single sign-on solution, whether it be an Oracle single sign-on solution or a Tivoli or you name it, RSA. But then, if we can't, and this is often the case in collaborative stuff, many different wiki sites and discussion forums have their own logon processes. So if I can't use single sign-on, then we should use federation. In other words, make sure we can federate the identity correctly such that the person at the other end is a specific individual who is writing that wiki. We need to then define roles which represent the scope of that wiki's audience or that discussion forum's audience and enforce that role in our application. So as we build our application and we federate out to these remote services, we're going to federate with the concept of a role is being allowed to use that wiki. People outside that role wouldn't get to it in the first place. More importantly, don't try and secure all the social networking in your application. It won't work. If you try and put all the security inside your app, then basically you're going to get to the situation that says, I can prevent someone going to the wiki through this URL. What's to stop them going through a different URL? So you use the application ACIs to change your UI, but you have to secure the back-end service with its own mechanisms to stop people getting access to the content. So one secures access to the service, the other one is going to secure access to the content from that service, and that's got to be the back end. And also, as I said, when you look at these collaborative services, remember that they are remote. So not only are you securing the content, you have to remember that you have to secure the network between them. There's no point securing the website if I can just get up with a sniffer and sniff someone's wiki page simply by using, because it's in the clear. So we need to look at what's the architecture to actually make sure we secure the piece of wire. And the obvious one would be SSL. It's not necessarily the best one. Okay, so if we look at a number of different services, and this it happens to be the sort of topology of the Web Center environment, the Oracle Web Center environment, Here you can see that we have a number of different collaborative environments, whether they be things like buddy lists and instant messaging, through to things like email services or discussion forums. And because they have different identity management solutions on the back end, there's no one cookie cutter that says, this is how my application is going to talk to them. So some applications, for example, a document repository, if we're looking at things like a Stellent or a Documentum or a Content DB, we can use web services to get to that particular service. So we have to look at how we would secure the web service. Other applications, for example, Wiki, natively takes advantage of single sign-on. So our identity is automatically passed there. But if not, we have to look at other types of applications. So for example here, an email service. If I was accessing Microsoft Exchange, how do I get my username and password from my Web Center application or my rich application that's written in JSF and get it to Microsoft Exchange, which isn't? Well, that's where the concept of credential vaults come in, or external applications. So what an external application really is a vault within the framework that stores encrypted credential pairs for a given application. So that information is in there. And when I call out to my service, I want to be able to pass a username and password to that application or to that service at the other end with the user's appropriate credential for Microsoft Exchange, and have it encrypted as such that no one can get to it until it's finally actually posted out there. So when you're looking at the framework, and most of the better frameworks do have this, but it's a sort of a mandatory thing if you're building these sorts of applications, you need it to be able to pass those credentials or automatically federate to those back-end services. As I said, in terms of the Web Center framework, that's exactly what we do. If there is a trust relationship and you can't do single sign-on, federate. We'll talk about web services security in a second. If not, then use a credential store, post those credentials to the back end, and grab the cookie that comes back. So when we're talking about federation, we're looking at secure identity propagation. In other words, how do I pass that I'm Barry to the other end and at the same time guarantee that I'm Barry? In other words, no one's played with the SOAP message. Well, the way we do that is by using web services security. And web services security basically digitally signs the sender information inside the SOAP envelope. So a SOAP envelope's made up of two sections, the header and the body. So the header contains information about who you are, the requester. So if I digitally sign that, I effectively encrypt it, put it in the header, it gets passed to the other end, and if they can decrypt it at the other end because they have the same key, then effectively I can tell that I'm talking to the right people, and therefore I must be Barry. So in that case, there's a number of tokens which are available. And the one limitation with web services security is it does require both ends to talk to each other. You physically have to call the other person at the other end and say, what token are you using? And what key should I use? So in other words, there's a trust relationship built up between the physical people at both ends. The web services security implements it, but you have to actually talk to the administrator of the service to say, how are you securing it? So there are three main tokens. The SAML token, which in this case is based on sender vouchers. It basically says, trust me. I'm trustworthy. You can trust me. Honest. Then there's two that use the username. Username token without password is what a lot of the enterprise applications use. And what that basically says is, here is my name, Barry, and I don't give you my password, trust me. In other words, if you can decrypt Barry, I must be the right person. Because we've chatted and we've handed each other our secure keys. So you can trust it. So either end trusts the communication. Username token with password is very similar to an external application. So in other words, you're passing credentials to the other end that says, okay, here's my username and password, again encrypted, but I'm going to assume you don't trust me, and I'm going to give you the full credential set so you can check it again. So applications which are very, very secure or untrustworthy, trusting if you like, tend to use this one. So username token with password gives a second authentication. Username token without password says, okay, you've already been authenticated, I will trust the authentication point and use that username. But as I said, once we've got the user, we're not going to set up our ACLs based on the individual user. We really are going to base it on roles. As I said, we're going to define a community of people who have access to our wiki. We're going to define a community who have access to our ERP system. But unless they're physically on the same server or on the same LDAP server, it's unlikely they're going to have the same definition of what defines human resources or what defines a viewer. So the framework also has to allow you to map your users to roles on the other end. Now, it's nice that web services actually allows you to do that. So effectively, if I have a role on this side called HR, in my wiki, the wiki manager made it HR department. So what we have to do is map HR to HR department and keep the two in sync. And your framework should allow you to do that. As I said, it's a fundamental part of web services security. The hard part is the framework keeping them in sync. So, for example, here's another screenshot of our Spaces application, which is actually, this is our out-of-box community-style application that's actually built using the framework. We've sort of been discussing this Jsf framework. But you can see here that we've taken the role model to two different levels. We have the concept of actual communities of individuals. So, for example, if I have a project, a particular sales project, then I can define users, the sales team, that make up that project. So that's the community. Then within the community, I can define roles of what people can actually do in a community. So in other words, you've got multiple levels of audience definition. If I then define a wiki to, for example, I have manage capability on only people who are logged in and public people can't see that, then that effectively means I go to my wiki, I go to my discussion forum or my content management solution, and if I'm not logged in, I don't see the content management. I log in, I suddenly get to see it. So you're defining the audience, and that's really all ACLs do. They define the audience who gets access to the information. And here's just to prove it at the other end. So here, for example, is our wiki server, and you can see that here we can define the various actions that someone can perform on a wiki server. Create new threads, create new pages, delete pages. That's actually, if anyone here creates a discussion forum or wiki site, the number one permission that you should implement is delete control. Anecdotal thing, there was a large corporation that we deal with who had a somewhat disgruntled employee who deleted 2 years' worth of pages out of their wiki server because they hadn't set up any security. So he knew he was about to be retrenched, so he literally destroyed 2 years' work, and all of their stuff had been done in wikis. So a simple checkbox of saying that person can't delete a thread would have saved that amount of work. Now, obviously, they had backups and they were able to do that, but simple checkbox made a big difference. Okay. If we have enough time, this is jumping into enterprise mashups. We have to treat enterprise mashups very much the same way as we treat social networking. It's sensitive information that's coming from somewhere else. And when we talk about enterprise mashups, as I said, we're looking at the ability to take information, in this case, this screenshot was from a mashup I did for a fictitious company where we had CRM information and, in fact, invoicing information from the Oracle e-business suite. So two completely separate development environments. And basically, we were taking that information and bringing it into a single transaction for a given company. Now, the problem is, we've just talked about web services. That information is out there. We're accessing it as a web service. It's secured information. It's sensitive information. So everything that we did for social networking, we have to take even more care when we're doing mashups or enterprise mashups because you're dealing with real information. You're dealing with sensitive financial information that's coming across the wire. So when we talk about mashups, as I said, we're really taking the Web 2.0 section. It looks like the network's gone down again, so we won't do the demo. But effectively, the implementing Web 2.0 things. But this is where we have to take a bit more care. So when we're dealing with web services in an enterprise mashup, not only do we have to look at secured identity, but we also have to look at signing the body. So we're looking at confidence. Is this the right person? In other words, am I talking to the HR system? Or am I talking to someone who's pretending to be the HR system? So once we've actually got the conversation going correctly and we know who we are at both ends, what's to stop me coming along and plugging a sniffer on the line and just reading the SOAP messages as they go up and down? Because SOAP normally is in the clear. So we need to look at signing the body itself. Now, a SOAP message, only the header is actually mandatory. You don't always have a body. But in this case, what we can do is use the same tokens to effectively sign the content. So when we sign the body, what it's doing is it takes that key and basically encrypts the string inside the XML file, and then puts the encrypted string in there, and at the other end, we decrypt it. Now, surely you could do the same thing with SSL. What happens if I just put SSL across there? The difference being SSL is encrypting the transport layer. You may not have access to the Apache server at the other end. You may not be able to define SSL on the transport. Plus, not every message going over that line may be required to be secured. SSL is still quite heavy as far as encrypting down to the transport layer. So what signing the body does is only effectively micro-encrypting only the bits that need to be encrypted. All the other messages can be in the clear. So when you're setting up these sort of rich internet applications, look at them as one, rich UI, how do I get the code back out of the server? Two, and importantly, think of them as compound documents, where I'm going to get information from lots of different services over the wire. So not only do I have to secure getting to them, I have to secure the information coming back again. And then once I've amalgamated and aggregated it in my server, only then do I push the rich UI to the client. So in other words, move everything back to the server. Keep your security, keep everything else on the server as much as possible. So just in summary, you can secure rich internet applications. There's no denying that. Just don't trust the client. Don't put your faith in JavaScript in the client or any other client-side processing, because you don't have control over the client, and even if it's compiled, there's nothing stopping someone taking time to decompile what you've pushed out there. Security is much easier to implement if it's based on standard policy mechanisms. So, for example, JAS-based policy on the server is a declarative way to specify who has which permissions on which actions within your application. So, in other words, take the security away from the application itself. It's not coded in the application. It's defined by a policy in a server, in a policy server. So, as I said, standards-based security separates security from the UI. Because it's part of the container and not the application, it also means it's hot pluggable. If I change my security model, I change my policy provider vendor, I can just plug it in and my RIA application doesn't change. If I put the security in the code and I change to RSA or change to IBM or Oracle or whatever, there are slight differences. I would have to write that code accordingly. Pushing it to the container in a standard way makes you agnostic. As far as Ajax is concerned, because you have a standard security model with standard identity and identity propagation, you can call out to those services and know they're the right person. You can have all your security and that the application can't call methods out of sequence because you've got to have a single sign-on to call it. I can't call checkout order unless I give it my single sign-on cookie. And the way you do that is have single sign-on. Okay. Well, unfortunately I'm out of time, so I won't show you the demo, but we'll show on the keynote. But at that point, any questions? Like? No? Other than, where do I get afternoon tea? Okay, well, thank you very much for coming. Hopefully there was some information there. If you have any questions, feel free to come up afterwards. Thank you.